Matthew, Nat, welcome to the show. Awesome to have you here.
Hey, Michael. Good to be here.
Thanks.
Yeah, it's been a while, Matt, since you've been on the show.
Every year or two, we got to chat. You and I chat at conferences sometimes too. It's always good to see you.
Absolutely. Yeah, it's always really good to see you as well. And I think, I think it's high time for an update.
Yeah.
And we talked a little bit a couple days ago about what the two of you are up to at Coiled. And wow, is it quite interesting, the things that you've been doing. It's really come a long ways and quite a bit more ambitious in terms of running data science in the cloud. So it's going to be a fun conversation with you too.
I look forward to it. I also brought Nat Tabris as a colleague here. I've stopped doing some engineering work these days. I used to be really smart, and now I mostly do engineering managery things or CEO things. So I've brought my friendly sidekick to actually explain real stuff.
Yeah, wonderful. I always love having a couple people on the show, get a little extra riffing off of the ideas and so on. So great to have you here, Nat. Welcome to the show.
Yeah, thanks.
Before we dive into cloud computing for data scientists and all the lessons you all have learned, let's just do a quick catch up. Matthew, you've been on the show a couple of times, but not everyone has listened to every episode. In fact, an interesting stat that just came out of the recent PSF JetBrains developer survey results is 50% of the people that do Python have only been doing it for less than 2 years professionally. So there's a lot of new people in our industry, and 50% of Python these days is data science, which I think that's a shift as well.
That's the beauty of Python, right? It's enough of a programming language that serious computer science people can get excited about it, and it's accessible enough that everybody can use it, and that's why it's become really popular.
Oh.
Right? Compare that to maybe
Yeah.
C++, which is very computer science focused, or maybe MATLAB, which is very user focused. Python can kind of bridge those two, and that's what's always given it, I think, its special status in the world.
I agree. And I think people, once they get started, they have lots of reason to stick. All right. All of that is a long-winded way of saying there's probably a lot of people who have not heard about you before. So give us the quick introduction on yourself. Matthew first, and then Nat.
Sure. So my name is Matthew Rocklin. I am a long-term open source contributor to the Python space, particularly sort of the data science part of Python. That started many years ago with projects like Tools, Multiple Dispatch, SymPy. And then maybe 10, 12 years ago, I started a project called Dask for parallel computing. And around Dask, there's lots of other projects. For the last decade, I've mostly focused on making it easy for Python developers to solve big problems with lots of computers and lots of hardware. 5-ish years ago, I started a company around that called Coiled, and now we do other things. But I've sort of been in that space in between Python developers and lots of hardware, and just trying to make that as easy as possible.
Yeah. First, you built all the packages for people to do cool data science stuff. Now you're building the infrastructure and clicking that together. Indeed. All right. Nat, welcome.
Thanks. So I'm Nat Tabris. I'm a software engineer at Coiled. Been here close to 4 years now. And my background is both I've done some research software engineer stuff, helping people use Python well, helping people use Dask well sometimes, and then also some sort of cloud SRE stuff. So Coiled is a lot of fun because we get to do the Python stuff and we get to do the cloud stuff, and we get to help other people do the Python stuff on the cloud.
Yeah. I think that's actually one of the interesting, non-obvious things of building data science tools and infrastructure for data scientists. Take Jupyter as an example, right? A lot of the work on Jupyter is JavaScripty type of stuff. But the purpose is to make it so Python people can do more Python without thinking about that kind of stuff, right? And you all probably have the sort of DevOps angle of that same thing going on there. You do a lot of DevOps, so many people don't have to do much DevOps at all.
Yeah.
Yeah, and most users don't have that capability, right? We need to make tools that live in a space, but that don't require deep expertise at that space. And that is, again, where I think Python brings a lot of power, sort of the old XKCD import anti-gravity comic, if you remember that.
Yeah. I'm flying. How are you flying? Well, just typed import anti-gravity. You know what was really funny when I was getting into Python was first learning that you could actually type that in the interpreter. It wasn't just a comic.
I didn't know that.
Yeah, if
every
you
day.
open a Python REPL and you type import anti-gravity, something happens. It has to be done, right? It has to be done. So, pretty amazing. Let's start with talking about sort of the evolution of Coiled. So, when we first started talking about Coiled, it's been a while, 3-4 years. I feel like maybe the first time you and I were on the show together to talk about it. Anyway, it was effectively Dask as a service, right? So Dask is a way to do kind of grid scale out computing with pandas and that type of work. And it would create a bunch of, you'd point it at a cluster and it would kind of spin up some machines and focus on like, how do I execute pandas-like work on a cluster?
Yeah.
And
Sorry, go ahead.
Go ahead. Yeah, no, go ahead.
So Dask did lots of things that weren't pandas. Pandas users are like 30% of Dask users. Dask
Okay.
it's a much more general purpose project than that. But you're 100% correct that the pain that we felt in the Dask community at a certain point wasn't to make Dask better. It was to make Dask easier to deploy, especially in the cloud. A lot of people were in the cloud those days, and it was just like it was a pain in the butt to bring up all the machines, set up everything correctly, to manage Docker things. And so we made a company around that. The weird thing that happened, so in order to run Dask effectively in the cloud, we had to figure out how to run Python effectively in the cloud. And so we made lots of interesting technology to do that. The surprising thing that happened is that a lot of our customers started using Coiled not for Dask things. They would like use Coiled to spin up a Dask cluster. They would kind of throw away the Dask cluster and just use the machines that Coiled had brought up for them.
Right.
And it turns out that like making Python run well at scale in the cloud is just like much more generally applicable than Dask in particular. And so like our customer base has shifted over time from being very Dask heavy to being more sort of just general computing heavy.
That makes tons of sense because, it's fine to spin up some bunch of Dask clusters, but really that was one specialization of, I just need a bunch of computers to run my data science workload, right?
When the engineers like Nat came to me and said, hey, look, we should do this thing. At first I was like, that doesn't make any sense. The cloud must offer just run this thing, bring up a machine, run some code on it, turn off the machine. Obviously the clouds must do that. I was like, no, they don't do that, or they don't do that well. There's like some APIs to do that, but they're really inaccessible. If you want, go to ChatGPT and ask it to like give you copy pastable commands to turn on 100 VMs and run hello world and turn them off. And like, it'll type at you for a couple of minutes. And it's not the kind of typing that most data scientist people who do use Python for a couple of years can do. It's actually pretty inaccessible.
Yeah.
I was actually quite shocked at how hard this relatively commonplace thing was to do.
I think a lot of what people do with data science, but also a lot of the courses, the tutorials, the libraries, they all lead data scientists away from developing those skills as well, right? They don't necessarily encourage you to start using Docker a lot, to start writing raw Linux commands. It's how can I make this work? It's not that they don't, but I think coming into it, like talking about those beginners, like the first 2 years of their job, right? They're still working on how do I do data science libraries, right?
Sure. I mean, that begs the question, should they? And like, my answer is like, maybe we shouldn't solve this by educating people. Maybe we should solve it by building better tooling.
Right.
Like I actually don't, like Docker is a great technology, but not necessarily for data science. Like Docker is very much specialized to provide like a really stable system that can run for decades. But like we want a system that can change every 5 minutes. Like the choices that tools like Docker or Kubernetes or Terraform make are actually quite different than the choices you would make, I think, if you were building sort of middleware for this audience. Those tooling, like the cloud gives you all of the things that you would want. It gives you this sort of fully flexible system, getting kind of hardware you want. It's infinitely scalable. It goes away when you stop using it. It's like very ephemeral. You pay only for what you use. But it's like pretty unusable. Like it's designed for cloud infrastructure engineers.
Right. If
We've
you're
built middleware on top of that, but that middleware is like not designed for our use cases.
yeah, there are a bunch of tools like Pulumi and others that'll spin up machines, but they're pretty different. And you hinted at it a little bit there. Much of the cloud infrastructure and APIs, just the way that it's meant to work is it's for a little bit longer lived systems, and it's more focused on web API development. How do I maybe take an API that's running on 4 machines, scale it up to 8 through auto scaling? Not how do I get 1,000 machines now for 3 minutes and then turn them off? That's different, right?
Yeah, I think a lot of the tooling that exists isn't really with our community in mind. And so when we built Coiled to run these Dask clusters, we looked around at other software, and we couldn't find something that actually like fit our needs. And as a result, we committed the cardinal sin. We rolled our own. And my hope, we're talking to folks today, is that there's actually we made some opinionated choices in doing that. I think we've actually come up with some interesting things that like use Coiled or don't use Coiled. I think some of the choices we made are actually pretty interesting. Some of the things we ran into in reconstructing one of these new frameworks, but in the sort of service of a sort of highly burst forward, highly flexible system, there's just some interesting engineering choices in there. There's some interesting experiences using the cloud at that scale, which I think people aren't as familiar with.
Yeah, I've seen some of the stuff that you've done, and it's really neat. It's not just hooking to this infrastructure, but it's down into programming idioms and concepts that make it almost transparent what's happening.
Mm-hmm. I think in building abstractions, you have to think a lot about what kind of things you abstract away from the user and what kind of things you give to them directly. I find for our users, we find that they really care about what kind of machine they run on. They like want to specify like the exact VM type sometimes because they want to have an SSD and an A10 GPU, and they want to be in this particular region where they're available. They like have a lot of opinions about that. And they have like 0 opinions about their networking setup or the security things other than please make it secure.
Yeah.
And I think in shaping abstractions, one makes some choices, and it's interesting to sort of figure out which choices to make and how to build something that gives that set of choices to a user.
What about cost? I mean, if I were to be doing this myself, if I were to spin up, hey, I need 500 machines for 10 minutes, I'd be certainly worried that what if I didn't turn them all off? I mean, that's catastrophically bad sort of things. You know, it's one thing like, oh yeah, okay, I left a GPU enabled machine on for a day and that wasn't pretty. But it's a whole nother to leave large, significant numbers of machines on.
Yeah. What else? Maybe let's do that. Let's spin up a bunch of machines. Might be fun. But Nat, first, do you want to say anything about costs? I mean, I think the cost story isn't just leaving things on. It's more complicated than that.
Yeah, I mean, it's like the cloud is really great and really cheap. Like you can do that if you do it right at, pennies or dollars. But there's I don't know if you see them, but I see like all of these stories of here's how I accidentally spent $60,000 on AWS. And it's always like, oh, I didn't even realize that, you could do it that way.
Yeah. And a lot of times it's a misunderstanding of auto scaling or something like that, right? There's a crazy story of this woman who wrote a AI or not image detection. She was a photographer, and she got really frustrated that there's all this AI generated art. And so she's like, I'm going to make an app that will tell you or only show you real art, not AI art, in order to have to filter a bunch of stuff, right? And made that serverless, and it became super like fifth, sixth most popular thing in the App Store, and it just scaled like it was supposed to. There was no downtime, but it scaled to like $96,000 and climbing for a sale bill. I know you guys talked about maybe a Kubernetes story with like a $50,000 surprise bill. These are not good things.
Yeah, I mean, the story you just told is actually, it's a positive one, right? I mean, like, she made a thing that was useful, and like a lot of people use it, and so it cost more money. Like, it's unfortunate that it was a surprising amount of money, but like, it was all useful work. I think what we see in customers pre-Coiled is like, often their costs are not useful work. A story from go ahead, Nat.
Oh, I mean, also part of, I think, what the cloud makes hard is these like guide rails. You're doing something that you don't know if it's going to be risky. And so part of what we try to do is like put in defaults, put in controls so that you can't accidentally spend that much money. If you don't know the cloud, I remember before being a cloud engineer, like, I don't want to sign up for this account and put in my credit card. I don't know what the bill is going to be.
Mm-hmm. Yeah, I think I'll tell two quick anecdotes. One is my first experience with a surprising bill. I was like in graduate school, signed up for Amazon. I was on their free tier, created some VMs and fooled around to turn them off. And then like 3 months later, I get a bill for $400. And it wasn't the VMs, it was the like attached storage to the VMs or some networking resource that had stuck around that I had no concept of. I wasn't there were abstractions I wasn't really aware of. AWS did a fine job. They actually refunded me the money. They credited it back. It happens all the time. But like, that's a case where the cloud is really complex, and it's really easy to shoot yourself in the foot with any complex system, especially if that complex system comes with dollars attached.
Yeah, and it's not just compute, right? That's, in your example, it was storage, but there's all sorts of little other services. Oh, I just spun up a database for that, and we actually inserted way more data than I thought, and then forgot to delete that or whatever, right?
And we've got thousands of customers who do the same thing, and then we run through those and we deal with them. So we've seen a lot of those same stories. Another story, sort of also pre-Coiled, but more sort of late in professional life. I was running, this is the $50,000 story you're mentioning. I was running a Kubernetes cluster for a customer, for a research group that I was collaborating with. And we're running Jupyter stuff and Dask stuff. They were all pretty happy. They had to learn Kubernetes we weren't super happy about, but like they were able to do things they couldn't do before and operate on scales they couldn't do before. And this was like huge. It was really exciting. And then 1 month, I got an email. It's like, hey, we burned through our annual budget last month. We don't know why. I was like, okay, what's going on? Everything seems fine in the logs, but like there's a surprise $50,000 bill. I said, well, the one thing that's different is that we're now running this 1,000 node job, but only for like 10 minutes every 6 hours. So every 6 hours, this job comes on, grabs 1,000 machines, and then turns off. Do the math, it should be like $10 a day, $20 a day. Obviously not thousands of dollars a day. And so what had happened is that their code brought up lots of Kubernetes pods. All the pods bring up, then 20 minutes later, they went down, everything worked great. But beneath Kubernetes, there was a node pool, and the node pool had attached an auto-scaling group, right? And that auto-scaling group had a policy. It's like, hey, if you need lots of nodes, no problem, we'll give you lots of nodes. But in scaling down, I expected the nodes to go away. And actually the policy was, if the average CPU percentage is less than 50%, remove one node, check back every 5 minutes. And so they were getting, 1,000 nodes, and then 5 minutes later they got, 999 nodes, and then 998 nodes, and that would decline very slowly, and then 6 hours later go back up to 1,000. And that policy of like, remove one node if CPU utilization is low makes a whole lot of sense if you are in the web services space, because that's kind of the cadence and the dynamic scales that occur.
Right. Ebbs and flows throughout the day, but it's not.
Yeah, but it makes
it's rarely
no
a huge
sense.
spike and then a huge drop. Yeah.
It makes no sense for the kind of users we deal with who want 50 GPUs for 10 minutes and then 1,000 CPUs for an hour and then nothing. It's like there's two different lessons here. One is that like the technology that we saw wasn't well tuned for our audience, for our user base. And also like there were just more abstractions than there needed to be. What I really wanted at the time wasn't Kubernetes and node pools. It was just like, I want 1,000 VMs. I wanted like EC2. EC2 was the right abstraction for me. I didn't want any other stuff on top. And so when we built Coiled, we actually designed for that. We designed for raw VMs. We call the raw VM architecture. And we just spin up 1,000 EC2 instances or 1,000 Google or Azure equivalents. We hook them all up dynamically, and then we shut them all down when we're done. And that approach is kind of weird. A lot of our customers, when they first see it, like, oh, that's odd. But it actually provides like a really interesting architecture that we found to be really interesting. If you're game, go ahead.
Yeah, I do think that is certainly what people want, right? You don't want to have one of these abstraction layers in there. You want I just need these machines. I need to run my code. But I think you're saying let's walk through an example, and I think that's great. I think one of the challenges that you're going to run into is like, how do you even make 1,000 VMs quickly and not spend most of your compute on machine setup and configuration and things like, even if you're not using some auto scaling, auto tuned down sort of thing, right?
Yeah, I think those would be the kind of problems we run into with 10 machines, but with 1,000, you run into other problems. There's all sorts of problems that'll show up.
Yeah.
I'm expecting the demo to kind of fail. I think it'll be interesting to see what happens. It's
all right,
weird
so
doing
everyone
a demo
listen
on a podcast.
I know.
Yeah.
Everyone listening, I'm going to narrate this very carefully. And if you go to the YouTube stream, you can watch it at minute 21, 25. But I will narrate it because there's some ideas, like the idioms and stuff that I spoke about. So
let me
go
start
ahead.
saying some things,
Yeah.
and then I'll hand off to you. And I expect actually Nat may have to interpret some things later too. So
All right.
I'm on my local machine. I'm in a Jupyter notebook, but I can be in VS Code or Cursor or whatever. And I'm typing in, I've imported library Coiled, and I'm going to create a Coiled cluster, just typing into Python some code. And workers equals 1,000. We'll ask for some ARM machines. We'll ask for Spot if it's available. If it's not available, fall back to on demand. And we'll ask for each machine to have maybe just a couple of CPUs.
All right, Matthew, before we go on, let's just talk about some of these things. You
Yeah.
go to Coiled and you say, create me a cluster. Workers is 1,000. That's 1,000 EC2 instances, right?
It will be, yeah.
That's insane.
Yeah. I'm also not going to Coiled. I'm going to my local Python environment. Here on my MacBook, Mac Mini is in Austin, but it could be on a CI job or wherever.
Yeah. Sorry. So by saying Coiled, I meant like you're using the Coiled API locally. Yeah. And then what are Spot instances for people who don't live in EC2?
Yeah, so Spot, also called preemptible in other clouds sometimes, are just instances that are cheaper because they don't have the guarantee of sticking around. The cloud can claim them back if some other customer willing to pay full price is willing to pay. And so we're looking for sort of cheap capacity. And then if it's not there, we actually are also willing to pay for on demand for full priced instances. So we're going to try to get 1,000, but we're saying, hey, if there's any discount things around, I'm happy to take them too.
Yeah. So the alternative is maybe you're going to set up, and again, this is more like the web API world. I'm going to set up an EC2 instance, and I'm going to configure my website on it. I'm just going to leave it running because my website should be up 24/7 in a perfect world. So I'm going to get a machine and just leave it. Those are often reserved instances, which have a different type of pricing, but a commitment to long term, right? You pay less by committing to pay for it for a month or a year or something. And so that's kind of the opposite of the Spot. It's like, hey, if there's any things that just happen to be hanging around, give us your cheap temporary ones, right? Okay, cool. So I think people get a sense of what you're going to go ask for.
Yeah, so let's just run that. So it'll take about a minute, maybe a couple minutes because it's a large number of machines. So the first thing that's happening is that we're scraping my local MacBook for all the Python packages I got installed. Every conda package, pip package, local .py file, local editable package. And then we are spinning up 1,000 machines. And so, go ahead.
Well, let's talk about that environment a little bit because
Sure.
It's fine to have 1,000 machines, but you are intending to write a bunch of code in Jupyter Notebook that probably depends on a bunch of stuff like what have you conda or pipped installed, in exactly those versions, and they might be uncommon things that you want to run, or maybe you have local files that you're going to subsequently say, load this CSV file or this Parquet file and jam on it, right?
Mm-hmm.
How does that stay coherent?
Yeah, that's a great question. So I'll actually add it, make it even more complex. Like, we're also running this first from my MacBook, but I'm actually running it on some Linux machines. And so like I've got to shift the architecture of those packages where appropriate. I may have private packages that are running, that I'm pulling from my company's local Artifactory repository. I may have packages that I've installed locally that I've like printed debug statements into. Like, things get actually quite hairy trying to replicate someone's local environment into a remote environment. And we try to do exactly that. We try to replicate as much as we can a local environment remotely. That could be data. You've mentioned data, like small files you might move, large files probably not.
Yeah, those might be pulled out of the like S3 storage or something like that.
Right? S3. But yeah, no, it's a complicated situation.
Yeah. And just a note for what's on the screen right now, it says you've booted 838 machines and working on the environment for 137 of them. That's pretty wild. We only got 160 to go.
Yeah. I mean, also things to note, like we got 54 M8G larges. Those are like the nice generation of AWS. And actually didn't know those were available. Those are new for me. We've got 942 M7G larges and 4 of the oldest generation M6G. So actually Coiled had to go to the cloud and get actually like a variety of different instance types because AWS ran out. In fact, maybe Nat, you can talk a little bit about like what just happened behind the scenes there. What are all the steps that we had to do in order to get those machines? They're also now all available.
Oh, nice. Yeah, so there's like all sorts of things that at the scale of like, I want 1 or 2 computers that just work, that like all sorts of things break down when you're asking for hundreds or thousands. So some of that is like, you can't just make individual API calls anymore. You would very quickly get rate limited, and then we would spend 10 minutes asking for these VMs instead of 15 seconds. So we use a variety of things. We use fleets. We use requests that again. So like this ties nicely with a spot where you say basically AWS, I want you to give me any of these range of things that have the best availability at the best price. So here, yeah, Matt is pulling up, and we can actually see how much spot we got. So it looks like we got a fair number of, actually, I don't know, what is that, like 4/5 of our instances we did manage to get spot, and those are going to be anywhere from like, I don't know, roughly half the price of a on-demand instance, sometimes more, but often even less. So they can be 30% of full price. Yeah, what else to say here? So
we were actually running this last night,
yeah.
And I was actually hoping that it would fail. It didn't fail, sadly. Let me see if I can bring up.
You have an odd hope for your demo, man.
Well, it wasn't us that failed. It was Amazon that failed, actually.
Yeah.
Amazon failed because it actually didn't have capacity.
Yeah. It turns out that like the cloud is unlimited until you start doing really big things. And then it's like, oh, you got to be clever if you want to get, and I mean, to some extent, everyone knows this nowadays with GPUs, right? GPUs are fairly constrained. But even when you're asking for just like 2,000 CPU instances, AWS often says, sorry, here's 200. Unless you know how to like frame that request in the right way. Right.
And you guys have solved, that's some of the gnarly DevOps you all have solved so other people don't have to, right?
Yeah.
All right, Matt, I feel like we should run some code on this thing now. You got them sitting here ready.
So I mean, what do you want to do? And this is the great question. This is a great problem of actually supporting Python users, I think, is that people want to do all sorts of different kinds of things, right? they want to load a bunch of data with pandas or with polars or with DuckDB, or they want to train a machine learning model with a certain kind of GPU or a certain kind of whatever. There's actually a lot of variety in what people do. And it's challenging to build a tool that provides, again, some of that abstraction, but not others. Like Snowflake provides the abstraction of SQL, and that's like a very clear thing to do. We provide the abstraction of, here's a machine that you can play with, do whatever you want to do with it. And sometimes that's Python code, sometimes it's other weird stuff. I'm actually, rather than show code, I might actually show a few examples of
Sure.
like,
Yeah, sure.
let's see. So like people will play things like with pandas, like what you mentioned, like machine learning, like climate science. There's all sorts of different weird things. We actually found that a lot of people would, inside of their Python code, they would like import the subprocess module, and then they would like create a process. They would run a process that was calling some other Fortran or C code that had nothing to do with Python. And so we found that. We said, great, let's go and let's support that by running, arbitrary batch jobs, arbitrary programs like, here in this example, I'm just like running echo hello world. So it's a weird set of problems to handle the infrastructure for this set of people, but not be very opinionated about what they do with that infrastructure.
Sure.
Does that make sense?
Yeah, absolutely. And so at this point, they pretty much have a machine if they can do it from a Jupyter notebook, they're kind of good to go.
Yeah, they have 1,000 machines, and those machines look just like their machine, just more numerous or bigger or with GPUs or whatever you like.
Sure. So how do I bring data back together? How do I fan it out? How do I map reduce or like execute a bunch of, I've got 1 million rows. I want to send 100 to each machine, or I don't know, whatever the math works out to be, 1,000 to each machine.
Yeah. Right. So now we're asking the question of how are we going to use the machines that we have? The answer to the questions you just asked me is Dask. You might use Dask to, hey, you got a petabyte of Parquet data on S3, use a Dask cluster. Or if you want, use a Spark cluster. We can spin up a Spark cluster, we can spin up polars, we can spin up lots of different things. And then now you're at the point of you're at the level of the sort of distributed computing framework. And they can go and run things with whatever distributed computing framework they like. Often, there's then a whole other set of problems they then deal with. Again, when we started Coiled, it was all around deploying Dask. But what we found is that actually, like most times, the problems they wanted to solve were not that complicated. They were not sophisticated. They were very simple problems. They had 1,000 Parquet files in S3. They wanted to do the same thing on each Parquet file. They actually didn't want to use Dask data frame. They wanted to use polars, say, or they wanted to use DuckDB. And so we would give them APIs that let them, so one example of an API is the Coiled function API. It's a decorator. Think if you're familiar with modals, something similar. And it does the same thing. It spins up a machine. You can run your function on that machine. And it goes ahead and spins up the VM, runs it, scales it down.
Yeah, that's really neat. And when you say on your website, it says serverless Python, is it the same thing as like... Term. Yeah, I know it is. I know. Is it still spinning up dedicated VMs, running your code on that, and then having going away, and you're just not thinking about it, or is it truly leveraging the serverless functionality that as AWS would refer to it in its console?
Serverless always means there's a server under the hood, but roughly the distinction is who has to worry about that server.
Yeah.
So. Yeah, when we say serverless, we're still using EC2 instances. Amazon, when you're running things on Lambda, they're still using EC2 instances. But it's an abstraction where you don't have to worry about that. You get those EC2 instances as you need them, you get them quickly, and you get them only for as long as you need them.
Okay, yeah, that makes a lot of sense. So this is something that really it really blew my mind here when you all showed me is you put a decorator at coiled.function onto just a regular Python function. And you can express things like the machine type you need, how many of them you want, and so on. And it just fires it up seamlessly behind the scenes when that function is called, and then it goes away, right?
Yeah, so this is all using the same underlying technology of what we joke about internally is that our core competency is turning VMs on and off. And so it's actually, once you have that technology, writing APIs around it is pretty cheap. And so a common API is a Python decorator. That's one of the various APIs we do. And yeah, a common application is I'm running PyTorch code and I'm using it on my MacBook. It's fine, but I'd like to use an NVIDIA CUDA GPU. Cool. Let's decorate that function with the GPU type that you want. And it goes ahead and runs that. And it runs locally in my environment. I'm still typing on my MacBook Pro in Cursor or whatever. But that function now, what it does is it spins up VM, runs code, keeps VM around for a little while, see if I want to run anything else on it again, and then spins it down. And that gives a lot of ability for the user to start experimenting with hardware, right? You can now run that function on any kind of GPU you want. And they do. They try lots of different things. We had a customer a long time ago this is when GPUs were at first very hard to get access to. And they would run through every region in their cloud trying to find A100s. And it's super easy in Coiled to say like, great, I want to run this in region EU Central 1. Let's see if Frankfurt has any GPUs. Nope, none there. Great, let's try this in AP Southwest, whatever. Let's see if Australia has any GPUs. And they would just, because it was now easy to play with things, it was easy to use the cloud, they started to experiment a lot more. And that was really valuable. We often see people playing with ARM versus Intel versus AMD, playing with different GPU types.
Well, yeah, I think something that's like interesting to me about data science. I mean, I to some extent come from the web world, and what you do is you just like you look at the list of instances, you pick one that looks, boring. You just use that. It runs for a year. You don't think about it. And so much in data science, it actually like makes sense to try out different instance types.
Yeah.
To explore, what's this GPU do for me? Sometimes that's really helpful. Sometimes it's not. To move around to different regions. So if you have a data set that's in one region, it makes like an orders of magnitude difference how quickly you can download it if you are close to it than if you are far from it. But even things like, specifics of the CPU family, we, for fun, we get to run like benchmarks on different things. And it's really nice because I just go in and like, oh, AWS came out with a new ARM instance type. And I can go like change one line of code. And now we run all our benchmarks on, as Matt was noticing, MHEs.
I was surprised to see MHEs. Have you run the benchmarks yet?
How
are they doing?
Yeah, I don't know if we have on those yet.
Okay.
But
What's the difference between 6 and 7? Do you remember?
I mean, all of these are the like Amazon designed ARM CPUs. Some of those differences are, the family of ARM. It's like ARM v8 versus ARM v7. Some of that actually really does make a difference for data science workloads because it has to do with those like wide instructions. So they're like mini GPUs that they're able to do many things in parallel on the CPU. Sometimes they put in better memory. So I think some of these new instances have DDR5 instead of DDR4. And it's like, does that make a difference for my workload? Is it going to save money? I can't tell you that a priori, but it's really easy to just try. And sometimes you're like, oh, wow, that, this hardware is like better, or, oh, wow, this new hardware actually doesn't make any difference for what I do.
Yeah, very interesting. It seems to me like the infrastructure you all have built makes experimenting way easier, right? If it's really hard for you to set up a machine, let's come back to this in a minute, but I have a question first. But I think a lot of times what people might do is, hey, instead of trying to do a lot of the scaling stuff, let's just set up one machine with 64 cores and a lot of memory and just set up a notebook server and we'll just configure it and let people have that. Yeah. I do want to come back to that, but while we're still on this ARM versus x86 thing, What's the story? Do you all recommend ARM in the data center these days for this kind of stuff, or is it still x86? What's the right choice?
You should try it. That's the short answer. But I mean, ARM is really nice sometimes. AWS is and a lot of the clouds are like really into ARM, so they're doing some really nice technology. They're offering it at a good price. It tends to run more power efficiently, and power is like actually one of the major costs at a data center.
Yeah.
But
I would love to run
depends,
ARM.
you know,
I would
just
love to run
try it.
ARM for my infrastructure.
Yeah.
But I'm concerned that there might be some native library or some
Yeah.
web server that doesn't run ARM, is not built for ARM or doesn't work right on ARM.
It's
A couple months in, like I want to add this one thing that would be really nice, but it doesn't work on ARM.
We've been doing this for a few years now. It's a lot better, the support, than it was like 3 or 4 years ago. But also this is like part of, so you were talking about, all of those tricks we do to get this seamless experience. And part of that is, people have Intel machines on their desk, or they have ARM MacBooks. They're running on Intel or AMD or ARM in the cloud. And all of this is stuff where like having to figure out, okay, so you have this software locally, what does that mean in the cloud? And it might be slightly different versions of things. It might even be you don't have a GPU locally, so you have the CPU version of PyTorch, but you actually want to use PyTorch on a GPU in the cloud. That involves, figuring out how to install the right versions of those different packages.
Yeah.
So in
That's
the screen
tricky.
share that no one can see, I've just switched my code to turn off ARM and switch from region US East 1 to US West 2. And we're just bringing up a new cluster. And if I had written some debug code in my code, that would also be updated. You were talking earlier, Michael, about experimentation being something to think about. I think that is one of the major differences between data workloads and web server workloads, is that the data world, like, usually there's eventually, yes, there's a production part where you're like running some model inference server, but there's this long period where you're experimenting, and really optimizing that period is really, really critical. And Coiled is very much designed to accelerate that experimentation process. Even like our choice to copy your environment rather than use Docker is highly informed by that. If you put in a Docker build, Docker push cycle into the data science work cycle, it's just like it gums everything up. People end up not doing it.
Yeah.
Coiled is smooth enough and easy to use enough that the cloud is now pleasant enough to actually include inside of the user dev cycle. And that's different, that's new, that's fun. And you can just play with stuff. So
that's
like
wild.
I've got now, 300 I got all the machines. I've got I've got 1,000 Intel machines and 1,000 ARM machines. What do you want to do with them, Michael? Right, we can run the same experiment right now inside this podcast. And that's, I think, the joy of this. And the cost of all of this is like dollars. That last cluster cost me $1.39. This one is costing me 45 cents so far, $80 an hour.
Wow.
This stuff
That's
is
actually
really
way
easy to
less
play
than I expected.
Yeah, the cloud is both like way cheaper and way more expensive than I realized going in, based on whether or not you're doing it correctly or doing it incorrectly. There's like several orders of magnitude difference. I know we want to talk about cost at some point, Michael. Maybe it's fun to talk through.
I do.
crazy stories.
I definitely want to hear some stories. I'm always here for stories. I first want to talk about the cost and the logistics of this one big shared Jupyter server sort of story versus this. No one's going to have, you asked for 2 CPUs per machine. I doubt anyone's going to have a 2,000 CPU single machine. I think they might exist, but they're very, very rare and they're very, very expensive. So what does the cost look like and the the challenges of some team that says, let's just set up one huge server and we'll just share it versus working like this?
Yeah, I think the short answer is like low tens of thousands of dollars for like an always-on 100-core machine. I'm honestly bringing up ChatGPT right now to ask that question.
It's such a special time we live in.
Yeah,
Before the machines rise up and kill us, it's amazing.
Yeah. Let's see what we got. Yeah, here we go. So let's see if I can bring this in. Yeah, so ChatGPT is telling me about $30,000 if I don't do any optimization. Yeah. When we see this in practice, people turn it off on the weekends, sometimes at night, sometimes not. Yeah. But like tens of thousands of dollars is typical.
It's expensive, but it's also it's rarely what people actually want to use, because so much you're like, oh, I want to try, sometimes you're like, oh, I have an idea. I want to try this experiment with like 10 different parameters. I want to search over some things. And you're like, okay, I got to do it. That's going to take me 10 days now because I got to run it one at a time. There's so much of like, I want to just try something that the one big machine doesn't let you easily do.
Sure. And if someone else is trying that experiment.
Right. And then there's also the like, oops, I ran
just
something that, made it crash. And then you're like calling your DevOps person, can you restart the...
Yeah, or you just ran something that took way longer than you thought it would, and you blocked it unintentionally, right, for little value, yeah.
I'll add some other things. Or you wanted to use a GPU. Or you wanted to now put that thing into production where it's running every day rather than you pressing a cell in Jupyter. Or you wanted to use Cursor rather than use Jupyter. There's many ways in which the big Jupyter server on the cloud is just it technically satisfies the requirement of running code in the cloud, but there's just so much more that we do as data professionals. We run things in production. We run things in different hardware. We develop in new ways. We experiment, and the job description is a lot more variable than that single machine is able to satisfy. Look at cars on the road. They're not all Honda Accords. You got semi-trucks, you got bicycles, you got pedestrians. We live in a world where we actually need a lot of different kinds of things. It's that variety that's actually really a core part of the cloud. That variety is something that we really care about.
Yeah, and it's very true to the data science ethos, right? Like we're going to experiment, we're going to explore, we're going to play, and if that becomes seamless. One of the problems is I want to experiment, but it's going to take 7 hours on my local machine. Mm-hmm. Could I ask that question and get an answer in 5 minutes if I'm willing to pay $10 or my company's willing to pay $10 or something, right?
Well, it's going to cost $10 either way. It's going to cost either $10 of machine time over a week or $10 of machine time over 5 minutes.
Yeah.
Just with 1,000 machines. And so I think you used a great word there, Michael, which is play. I think a lot of why Python became popular is that it feels like play often. Like we're given these libraries that are both easy to use and powerful, and that feels like play. We get to oh, this is a cool squirt gun. I can press this button and water shoots out. I can go shoot my friends. Isn't that fun? Right? And if you look at using the Boto library in AWS, that does not feel like play. If you go look at thinking about writing YAML in Kubernetes, it does not feel like play. No. But here today, we got to play with making 2,000 VMs, half ARM, half Intel, half on the US East Coast, half on the US West Coast. And we didn't do any work with them, but we could have. And now suddenly the cloud is like play. And you just do different things when things become playful. You behave differently. And that's really the fun thing. Folks have fun. And the cloud is a really fun tool to use once you get past all the pain.
I agree. When you first hear about it, you're like, wow, what can I do with this? But then you get into working with Boto and you just kind of want to stop.
You do. Everyone stops.
Nat, you probably spend more time with Boto than any of us.
Yeah.
You take one for the team, for all of us. Thanks.
Yeah. A lot of reading API docs so that you don't have to.
Yeah. All right. So 2 questions here. One, we've started these clusters. Are both still running? Is one just still running? if I do this in a notebook, how do I ensure that it does shut down, that I don't let it run for too long, like unnecessarily long, right? What's the workflow with that?
Yeah. So broadly, how do we constrain costs, and how do we make sure that things are as low cost as possible?
Yeah.
So one already auto shut down. So we weren't using it. Coiled saw we weren't using it. It shut it down. We can bring it up again. It takes a minute. So it's easy to bring things back up and down. If you wanted it to stay up, there's keywords to control all of that. But default behavior is to shut things down pretty aggressively. The other one is still up. We can go do things with it if you like.
Yeah. Could you
it's
set
fast.
timeouts in the cluster when you create it?
Yeah, 100%.
Yeah. Like idle timeouts. Yeah.
Typically what we do is if people do want to have something that sort of sits around for a while, they'll set an idle timeout and they'll give it a name. And at the top of their script, it'll say, hey, I want to use my cluster named prod or whatever. And it has an idle timeout of an hour. Make sure that exists. And if it doesn't exist, we'll bring it up. If it does exist, we'll connect you to it. And that behavior works really well.
That's cool. So you can do things like restart my kernel in notebooks and then just like reattach to it rather than, well, now I have 7,000 server clusters. How'd that happen?
Sure. Yeah.
That's the opposite of what you're preaching here.
Yeah. Sometimes if you do want to change your code, if you're like when I work on Dask sometimes, and I need to put a print statement into some code because I want to see what's happening on my cluster. At that point, I'll then recreate a new cluster because I need my code to be re-pushed up. But I can go to the logs and I can go look where all my print statements are, and they're there. Like, oh, that wasn't quite right. I'll change my print statement, make a new cluster. 1 minute later, things are up again. Again, that sort of minute-long thing is not perfect. I wish it was a second, but like a minute does tend to be within the dev cycle tolerance of a lot of humans.
Yeah. And you asked for, I was just thinking, like, how could you sort of preload these types of things? Like, at some point you could have just 1,000 machines hanging around. You always, like a pool you hand out. But as we've been going through, you have all these variations. I want an ARM one. I want an x86. I want one with a GPU. I want one with this GPU. I want it in that region. That makes it really hard to like completely just have a whole bunch, like a fleet of them ready to just hand out,
So much of what we try to do is like play that balance between speed and flexibility and low cost, right? So like the more you keep things sitting around, the more you're paying for them. I think we've got like, if you can get it faster than someone can go get a cup of coffee, that seems to be a much better experience.
Yeah, that seems fair. And also if you can get it faster than your experiment is going to take to run.
Yeah.
Right. Then it's kind of.
Yeah, you would not use Coiled to like back up a web API endpoint that has to get back to human in response time. You should go use Lambda, you should go use Modal, you should go use something else.
Yeah.
You should use Coiled when you're using enough hardware that it would be prohibitively expensive. Like you actually don't want to have a pool of 1,000 machines sitting around just in case someone wants them. That doesn't make sense. You should use Coiled when you have these other larger things to do. And again, I think that sounded like I got back into pitch mode. The point I wanted to talk about here isn't use Coiled. It's the cloud actually has these capabilities. You can get 1,000 VMs anywhere in the world of any hardware type you like for dollars. And that's actually an incredible capability if you can do it right. I think today the zeitgeist is go use Kubernetes. And like we just think that's dead wrong. The answer is just go use raw VMs. They're actually pretty good if you do a few things around them. If you figure out software environments, if you figure out how to sort of batch requests, if you figure out how to handle logs, if you figure out how to do low cost.
Yeah.
But like this is, I think, actually the right foundation, I think. Like the raw VM is maybe the right foundation for a lot of data work.
Yeah. How about just pick a library and infrastructure that's exceptionally tuned to, I need to start them as fast as possible, run it one job and shut it back down. And I don't think serverless in the AWS sense is really going to be the way, because serverless gets expensive if you have too much compute. Just ask Kara.ai, right? That's the $96,000 Vercel bill.
Yeah, serverless, Lambda, and similar technologies typically have like a 4 to 5x premium on cost. They also have limitations like you can't get big machines, you can't get GPUs. Your software environments have to be of a certain size.
They can
Like,
time
that's
out,
what you
right?
can't do.
Yeah.
They can time out. But like mostly we see people who like want to run their Polar's job, not with 16 cores, but with 64 cores. It's like Lambda isn't going to cut it. And so you want the full flexibility of the cloud.
Yeah, absolutely. What's a typical size? I mean, you created 1,000, you guys, to be, and that's super impressive. But is that common?
Nat, can you talk about? I think that's just,
Yeah. I mean,
go
we
ahead.
see all sorts of things. So this is like you give people a flexible tool. It turns out they use it in so many different ways. We actually have like, we were a little bit surprised to find how many people were doing things on one VM. So we had a whole bunch of users, and this sounds less exciting, but like who would just have like individual scripts that they needed to run on a cloud VM, and this is the easiest way to do that
Oh,
whenever
that's
you
interesting.
need to.
Yeah,
and then we
because
have
you get
other
lots of
users- yeah.
well, sorry, you get a lot of benefits of that maybe don't fit the mold, but here I can put a decorator on a function,
Yeah.
and this function runs on a big machine in the cloud right next door to the storage in S3 where the Parquet file lives,
Yeah.
or something like that, right? It has more memory than, I don't have enough memory, but this one has enough memory, or whatever, right? And that's
Yeah.
actually pretty neat.
Yeah. And then we have other users who are making, multi-thousand node clusters, and that's a whole different set of challenges. At that scale, you start like actually hitting cloud limits of like capacity, and you have to do tricks like basically using multiple, they're called availability zones in AWS, so like multiple data centers. And
Can one of these clusters
Yeah.
span availability zones or regions even?
So we don't span regions with a single cluster today. We haven't found people needing that scale, and that's yet a new set of challenges. But yeah, we very commonly do multi-availability zone clusters. This is Matt's pulling up some docs and examples, but something that this is actually really nice pairing with is if you want big spot clusters. Spot can be really cheap, but it can also, there isn't as much availability of it because it's so cheap. So this works really nicely. And I'll say like all of these things, sorry, my life is all about like trade-offs and edge cases. So all of these things have like, you got to be careful not to do it in the wrong way. So with availability zones, one kind of gotcha is you pay for moving data between availability zones.
Right. So a simple read Parquet file that
Right.
happens to go across you do that a bunch of times, all of a sudden, across 1,000 machines, but back and forth. You're like, whoa, there's your surprise.
Well, it's tricky actually because read Parquet is fine because Parquet is probably on S3, and S3 crosses all of the availability zones in a region.
Okay.
But
Yeah.
if one machine loads data on one availability zone, then transfer it to another machine, another availability zone, then you pay. And people
see.
don't know that.
Yeah. I mean, things like if you need to shuffle or sort your data set, but also just like if you're doing naive things in terms of like pulling back your data all through one machine. And so part of what we do is like make it easy to control that. It's like, again, one parameter. You can say, I do want multiple AZs. I don't want multiple AZs. But then giving people like, you can look at network metrics to see, I think my workload is embarrassingly parallel, so this is fine. Let's take a look at metrics and see, this workload makes sense to span AZs, get more spot, save more money that way. This workload, we want to keep this in a single AZ. We're going to let AWS pick it so that they pick the one that's cheapest and has the best availability. And that's all stuff that we like automatically do.
I want to double down on that for a second. I think Spot is a good example of like this is one of 100 things you have to do well. I think a lot of what we found is that like using the cloud well isn't doing one big thing right. It's not like one magical thing that's done. There's a long tail of a lot of small things to get right. There's a lot of nuance and a lot of polish. Spot's a good example. So we were running benchmarks internally, and they were costing us some money, like our own like Dask benchmarks back in the Dask focus days. And we was like, great, we'll switch to Spot. Easy to do. And the engineers hated it. the Dask engineers hated it because like all the benchmarks became very variable because they asked for 100 machines, but they got 70, or they asked for, or like machines would go away. And so we did a few things. One is what I said before, the sort of falling back to on demand. Okay, if you only have 70 machines, it's okay. Give me 70 spot and I'll pay full price for 30. That's a feature people really like. Another one is availability zones, right? So at any given hour of the day, a different data center in US East 1 has more or less spot availability or GPU availability. And so we'll look at all of them. We'll say, okay, this is the data center, this is the availability zone that's got the most available right now. And so we'll go to that one and we'll pull from there instead. There's things like that that are known to cloud experts, but are just like not something your average data person knows to think about. And those are the kinds of things that you should abstract away and that we do. And there's 100
really nice.
similar things. And so again, if you want to get GPUs, you got to make sure you're looking at across the region. But if those GPUs are going to talk to each other, you got to make sure you're looking across the region and then focus on exactly one AZ and not go across. So there's a lot of sort of this interesting sort of, again, nuance to doing this stuff well.
Right. If the machines become chatty with each other, you want them all next to each other.
Yeah, it's like it's 1,000x more expensive than, and I'm saying 1,000x without hyperbole. Like you can process data 1,000 times cheaper on a machine than you can transfer it between machines.
Compute tends to be like a fairly predictable part of the cost. It's all of these other things that you don't even think about. Like, oh, if I flip this setting, now I'm hitting this S3 API a lot, and it turns out you pay per API call. I didn't know that until that was $1,000.
Now, there was a XGBoost debug log example. Do you want to run through that?
Yeah. So I mean, logs is another thing that like most of the time that's effectively zero money. But then we do things at the scale where like someone was running 1,000 node cluster. I think they had something that wasn't working well, so they turned on debug level logging, and it gave very chatty logs, and I think it was like a $15,000 bill, and that's the sort of thing that like it's not even in your mind as a possibility until you see that. That had a happy ending because we talked to AWS and they ended up eating that cost for the customer, but
also a good lesson. If you talk to AWS, they'll give you money back.
Just don't keep crossing those boundaries too many times.
Yeah. I mean, right. And part of that was like, what controls are you putting in place so this doesn't happen again? And so we do some things to like, now we warn if we see you have very chatty logs, we say, hey, you might want to turn this down.
Yeah, absolutely. So when I create a coiled cluster locally, and it's going to go do all the magic that we've been talking about, what is the payment workflow? How is it distributed? Do I have an AWS account that I register my card with AWS, and then Coiled uses that account, and there's some kind of fee to Coiled, but then mostly I pay directly to AWS, or do I pay you all, and then you all like, what does this look like?
Yeah. So, I mean, we do have a kind of trial thing that will run in our account, but primarily what we provide and what people want is running compute in their cloud account. And we do that in part because it's simpler, but we also do it because a lot of people have their own data in their own account, or they have security requirements, or special networking needs. But
maybe special arrangements with pricing if they're a big
sure,
customer,
yeah.
right?
So if they have contracts with AWS, they will just use whatever that discount is.
Okay.
The flip side of that is like people might have AWS accounts, or we have plenty of people who just like they see that Coiled uses AWS and they sign up for a new one, and they don't know how to go in and set that up. So something that is actually kind of cool that we do that like really isn't part of running clusters, but is a necessary thing to do, is make that setup really easy. So part of what we're doing is, using some like best practices around how to manage those credentials, how to set up the networking resources in ways that don't have a standing cost but are secure. There's all sorts of things that like people, if you're a data scientist, you don't have to think about NAT gateways. And we think about that stuff. NAT gateways are like one of the famous ways to spend a lot of money on AWS. So we'll set up the network in a way that is secure but doesn't use NAT gateways, and we do that automatically. We do that. We have a web UI for that, and I really like it because I worked on this. We have this like lovely CLI tool that does that setup for you. Has a lot of rich widgets.
Nice.
And so it's trying to make that whole thing so that, in my mind, it's very important to like make the easy case easy, but make the hard case possible. So if you don't know all of this cloud stuff and you just want us to like give you sensible defaults, we'll do that. If you are a data engineer who your company is giving you a whole bunch of requirements for how the network is configured, we can support that.
I think a big design consideration, we're making Coiled, like Nat and I actually collaborated a bunch and fought a bunch on the setup process. It's like the setup process is something that we care very deeply about. Like we would go to conferences and just sit down with just like run-of-the-mill new Python data developers and say like, cool, can you set up? And we would have them do it. And they had no idea how the cloud account worked, but at some point, some of the company had given them some like AWS credentials file. And like all of that will work. Like you can say pip install Coiled setup, and just like press enter a few times, and we will set things up for you in a way that is sensible. Like I think we make the cloud accessible to people who don't really know how the cloud works that well. So if you're thinking like, oh, I'm a person who knows pandas and NumPy and Scikit-learn, and I happen to have this cloud account, you should try out Coiled. Coiled is actually designed for you. It's not designed for your IT department. But as Nat said, Nat talks to lots of IT departments. They love us too. But the UX around that is especially smooth.
Yeah, it looks really great. All right, guys, we are pretty much out of time. Final thoughts for folks out there before they get to the end of the show. Maybe they want to try Coiled. Maybe they want to try their own crack at something like this for their team, or what do you think?
I mean, the standard call to action is like go to Coiled.io. Like it's easy to use. Have a good time. I think more broadly, the thing I want to say is like the cloud provides a promise that is great for us, but isn't actually delivered that well. And they shouldn't accept or tolerate the like kind of shitty data platform. Like this can be a delightful and a very powerful tool for the data space. And if it's not, maybe don't use Coiled, but like use something and like have high expectations. We should have a degree of taste and a degree of standard. And we can meet that standard. I think there's actually a lot that we can do here. There's a lot of potential that's really exciting.
Yeah, absolutely. Nat?
Yeah, all of that sounds right to me. I will report like I think this message of like it is okay to be unhappy and things are supposed to be delightful is important to us. I spend a lot of time being unhappy, hopefully so that other people will be able to have delightful experiences.
Yeah, absolutely. It should be delightful. It sounds delightful when it was created, and it's gotten really complex, but it doesn't have to be. I guess maybe a lesson I learned from this is use tools optimized for data science workloads. Don't use tools optimized for long-running web apps and other things like that you hear about all the time, but they're not for you necessarily.
Yeah, and it can be a delightful experience. I like the term. Like we should all be playing and come by and play. Or again, if you don't want to use Coiled, that's fine, but like there's other ways to do things. Go play.
Awesome. All right. Well, we will call it a wrap on the show, and people can go play. Guys, thanks for being on the show. It's been really interesting. Thanks. Cool. And congrats on such a cool company, but also service. This is really neat.
Thanks, Michael. Thanks for having us.
Yeah. Yeah, you bet. Bye all.